Hello and welcome to today's daily Leetcode challenge. Let's solve question 872, leaf similar trees. So for those of you who don't know, a leaf is a node in a tree that doesn't have any children. So usually they tend to be towards the bottom, and here they're highlighted in blue. Consider all leaves in a binary tree from left to right order, the values of those leaves from the leaf value sequence. Consider all the leaves of a binary tree from left to right order. The values of those leaves form a leaf value sequence. Okay, so the leaf value sequence in this case is 6, 7, 4, 9, 8. For example, the given tree below is 6, 7, 4, 9, 8. Okay, cool. Two binary trees are considered leaf similar if their leaf value sequence is the same. Return true if and only if the two given trees, which are root 1 and root 2, are leaf similar. Okay, so let's solve this question step by step. First example is 6, 7, 4, 9, 8, 6, 7, 4, 9, 8. So you can see the trees are different, however the leaf value is the same, and it's in the same order. On the example 2, we have two different trees. Their leaves aren't similar either. Okay, so yeah, let's solve this step by step. I propose first creating a function, a deep first search function that's going to create our leaf value sequence for a tree. I'm going to call this res and say that def DFS, this is our standard DFS search. If not node, then return. I'm also going to have this non-local res, this access to the res. And now let's call DFS on node left and node right. During this time also, we're going to say that, so how do we figure out that that we're hitting a leaf node? Let's say that if node is not at all passed down, then return true. What does that mean? That means that if I am looking at a 6 and it doesn't have a left node, then the value that gets returned from DFS of looking at the left portion of the 6 is true, meaning indicating a leaf. Let's say that left is now equal to DFS of node left and right is equal to DFS node of right. What that leaves here is that if left and right, we must be in a situation where DFS on the search of the left node returned to true, and DFS on the search of the right node also returned to true. That's only the case if we're looking at a leaf node. So this condition here will only be executed if we're looking at a leaf node. Res append node value will then give us a res filled with the value 6. So on, recursively is going to be filled 7, 4, 9, and 8. In the case where node is not, or left or right is not, in the case where node is present, then we return a false, indicating that we're not a leaf node. Let me call DFS on root 1, and let me print res. Return, for now, let's say return false, temporary. We should be set. Let me print this and see what we get. Standard out is 6, 7, 4, 9, 8. Cool. What my suggestion here is now let's keep track of not just one res, but also another one that will be coordinated with the other tree. So let's say that res 1, and then we have another res 2. Let's keep this res, and I'm actually going to get rid of this. I'm going to have a res here that I pass with my DFS. let's have this also be a res and this also be res. This same res is going to be different for the DFS that gets called for root 1 versus DFS that gets called for root 2. So res 1 goes here, root 2 with res 2 gets called here. All that's left to do now is compare res 1 with res 2. Let's see if this works. We get an accepted solution. Let's submit and see if this is fine. We are set. Cool, then this puts us at a 76th percentile, not bad. Let's see what some of the other solutions are. DFS is... Right, the other approaches here would be to somehow synchronize the traversal of both of the trees, which I feel like is unnecessary. Let me see if there's something similar to this towards... What they're doing here with the yields is the synchronization. They're turning the DFS function into a generator, which is out of the scope of what I want to get into. There's a really good solution here, and it looks like they're getting around around 89% percentile, and they're doing the same thing here. So I'm actually going to, I'm going to say that we're doing fine actually, and it's perfectly, viable solution. All right, well then, in that case, thanks for watching. Please use this if you want, like and subscribe, and I'll see you tomorrow. Bye.